Today's lecture 10 of Basic Electronics is about CMOS. Welcome to our channel ClassFly community. So today we will be doing CMOS inverter, and from the topic the first question that arrives is what is inverter. So we have done in basic gates about not that it do inversion, that means whatever we give as our input we will get the opposite as the output. So we have done inverter by using the basic gates. Now we have to perform the inversion operation with using the CMOS. So if you are asked what is inverter, you will say that an inverter circuit outputs a voltage representing the opposite logic level to its input. That means if my input is 0, I will get the output as 1, and if my input is 1, I will get the output as 0. That means if my input is A, then with the using of the NOT gate, I will get the output as A complement or A dash, right? So see, then what is CMOS inverter? CMOS full form is complementary metal oxide semiconductor. So we will now do the CMOS inverter. That means we will use the inversion operation and will verify does the CMOS inverter also show this operation, that when we give input as 0 we get the output as 1, or when we give the input as 1 we get the output as 0 or not. So basically see, CMOS inverter is the combination of the N MOSFET and the P MOSFET. That means in the N MOSFET, the current moves from the drain to source, and the PMOS current moves from the source to drain. So this is the difference between the NMOS and the PMOS. So complementary MOS can be designed by N MOSFET and P MOSFET. You just remember that NMOS current flows from drain to source and PMOS current moves from source to drain. Okay. Now see, this CMOS, it is a very high speed logic family. It is in a logic family, so it has a very high speed, and this CMOS can be used in small scale integration or it can be used in medium scale integration. So now let's move on and perform and see how the circuit looks for the CMOS. Okay, see, this circuit looks like this. What is this? What is this circuit? Don't get tensed. As I told, it is the combination of the PMOS and NMOS. So how will you identify which is the PMOS? So the PMOS will have a bubble in front of the plates. So this is your PMOS. That means this portion is representing your PMOS, and we are representing here as Q1. And as I told, PMOS current moves from source to drain. Okay. Similarly, how we will identify the NMOS? Which will not have the bubble in front of the plate is your NMOS. Okay. So here we are representing the NMOS as Q2. And the specialty of this circuit is that this PMOS will be at the high, that means it will be connected to VDD, and this NMOS will be connected to ground, that means it will be low, and both of them has been short circuited. That means both of them inputs will be same. Whenever we will give the Vin, if we put Vin 0 for this one, then the input for NMOS will also be 0. Okay. Similarly, their output also has been short circuited, and NMOS current moves from drain to source. Okay. So here also their output has been short circuited. So this is your basic diagram. So if you can't understand this, I made this for your understanding. So you will refer this one, okay? Now see, I am making this one again. So see, this is our input. So we will write V in as the input, and first we will short circuit. So one will be for the PMOS. So PMOS has the bubble, and here as the plate, and it will be with the high. Similarly for this, we will make a plate like this, and like this we will make the NMOS, and it will be grounded. So this is our NMOS and this is our PMOS, and this will be our output. So now let's see that it says we will give the input as 0. So I am giving the input as 0. So for this PMOS, the input will also be 0, and for NMOS also be 0. But as it is the bubble is here, it will change to 1. That means our Q1 will be on and our NMOS will be off. So whenever we will give the input, our NMOS will not work. Only our PMOS will work. So as our PMOS will work here, so whenever we will give the input as 0, we will get the output as 1. So that means we are getting the inversion operation, that is for 0 we are getting 1. Okay. Now let's make the diagram one more time. So it is input. We will short circuit it, and we will make for one PMOS, and it will be VDD. Similarly for this one also, that will be our NMOS, right? So this is our NMOS which will be grounded, and this will be our output. So this is PMOS, this is our NMOS. So now we will be providing the input as 1. So for PMOS it will be also 1, and for NMOS also it will be 1. But as PMOS having the bubble, it will be 0. But for NMOS it will be 1. So that means in this case PMOS will be off. So for 1 our PMOS will be off, and for Q2, that is our NMOS, will be on. That means whenever we will give the input as 1, we will get the output as 0. That means whenever we are giving the input as 1, we are getting the output as 0. That means CMOS is fulfilling the inversion operation. Fulfilling the inversion operation. So this is our truth table. This is our circuit diagram. Okay, and I hope you all understood the lecture of today. So please remember that PMOS is always moved from source to drain, and NMOS move from drain to source. So thank you very much, and see you all in the next lecture. Till then, be happy and have a great day. Now is the code time. Very often the change of self is needed than a change of sense. I hope all of you understood the lecture of today, and thank you for watching.
Wow, that's impressive! You have completed a magic today. For more videos, subscribe. Join our Facebook group and Instagram page for group discussion and live magazine videos for exam preparation in an hour. We start at ClassFly community for students to learn from a friend in a simple way and support them in their own languages. If you are willing to be that one friend who saves us at the exam night preparation, then please join us by visiting classfly.in.